So welcome to day 2 of our unit 3 of vectors. We're going to look at vector components today. So what that means specifically is we're going to calculate the vertical and horizontal components of a vector. So hopefully you have a good understanding of what a vector is from our first lesson. Okay, if you don't, make sure you're asking me about that or asking another classmate to help explain it, because you need to understand what a vector is. Okay. This homework for this lesson for day 2 does get a little repetitive because it's going to be the same thing, calculating the vertical and horizontal component, but it is awesome because it gets you used to and understanding what that means, okay? So when we're describing direction, sorry, I'm going to take this out here. When we're describing direction, you're going to do that in homework tonight, okay? There is something that we call a true bearing and something that we call a quadrant bearing, okay? So a true bearing is often you will just hear bearing, okay? At a bearing of whatever it is, 40 degrees, okay? Angle measured clockwise from north. So there's north, and so you're gonna go around clockwise, okay? Expressed in 3 digits, okay? So an example would be 150 degrees. So if you were to do that one, or an example would be 0, 20 degrees. Notice 3 digits, so you have to put that 0 there, okay? So an example would be 150 degrees. I know that we just did our trig unit where we would have done this over here to 150 degrees. This looks like it's like a negative angle, but remember we're measuring from the north, so it is 150 degrees from the north, okay? Or and that example would be that 20 degrees there, 0, 20 degrees. Okay, so don't get confused. It might take you a little bit to remember that, but remember that it is always from the north. Okay, a quadrant bearing is an angle measured east or west of the north-south line. So it means that it's always going to be acute, so it's going to be between 0 and 90 degrees. Okay, and so an example would be south 30 degrees east or north 45 degrees west. So notice you always start with south or north and then you follow up with east or west. Okay, so an example, south 30 degrees east, start at your south and then you're going to be going back to east by 30 degrees. So this angle in here would be 30 degrees because this is your south. Okay, north 45 degrees west, well, north, you're going to be going towards the west by 45 degrees. Okay, so always measure from your north and south to your east and west. Okay, so that takes a little bit of time to get used to, but you will get used to it. There's lots of examples for you to complete. Okay, so just make sure we're measuring from our y-axis. Okay, so now specifically looking at our component vectors. Any vector can be resolved into its perpendicular components. Perpendicular, remember, is like that, okay? One going straight up, and then you have a 90 degrees going opposite. So this would be this is vertical, and then this would be horizontal. Okay, so if we were to draw a vector, so a vector can be resolved, that means that this vector can be resolved into its perpendicular components, meaning our horizontal component and our vertical component. Ooh, what does this look like? Our trig. Okay, so that means that we can find out this measurement quite easily by using our vertical and horizontal components. So if you wanted to find your hypotenuse, essentially, or you wanted to figure out what your horizontal component is or your vertical component is, all you're going to do is use SOHCAHTOA. Okay, so to figure out your horizontal component, to figure out your horizontal component, you're going to find x, okay? Which, to find that side, you're going to take your adjacent, because that's the side that it's labeled, and use your hypotenuse. Well, adjacent and hypotenuse is cosine, okay? And then you're going to take your cosine of your angle, whatever your angle is, and just times it by this vector, okay? Again, this will make more sense when we do examples. Or you take your, to find your vertical component, well, you need opposite and hypotenuse to find that. So you're going to take v times the sine of theta to find your vertical component. Okay, so we are going to do a couple of examples here so that that makes sense. So find the vertical and horizontal components of the following vector. Of the following vector applying 200 newtons of force on a bearing of 0.41 degrees. Okay, so you're going to want to draw that. So here is your vector. Okay, it is going to be labeled as 200 newtons because it told us that 200 newtons is the force. And then remember, because it is on a bearing of 41 degrees, you start north and you're going to rotate 41 degrees. Okay, so you're going to find your horizontal and your vertical components. Okay, however, we need to find our theta in here. Well, what is theta? It's going to be 90 degrees minus that 41 degrees to equal 49 degrees. Okay, so you need to make sure that you're finding the one that's in the triangle you're using. This one is, that 41 degrees isn't in your triangle, so you need to make sure you find theta. Okay, then you can find your horizontal component. So it's your x, right? We're finding x. From previous, you want to put your vector. Okay, your vector is 200 newtons. And then you're going to take the cos, because cos was for our horizontal component, and then a 49 degrees. So when you plug that in your calculator, you are going to get 131.2 newtons. And then remember, we are going east here. This would be east, so your direction is east. Don't get confused, this n, because it's not in the brackets, is your newtons. Okay, so don't get confused there. Direction, if you want to get specific, put it in square brackets. Okay, then to complete our vertical component, that is our y, we're still going to take our vector v, which is 200 newtons, and times it now by the sine of 49 degrees. Okay, you should get 154.4 newtons. And then in this is our direction here, and that is north, because our vertical component goes north. Okay, so this is horizontal, and this is vertical. Okay, so let's do another couple examples. I think two examples so that you're getting really comfortable with this. Okay, so find the vertical again and horizontal components of the following displacement vector: 430 kilometers south, 58 degrees west. Okay, so you're going to draw 430 kilometers, and because we always measure from south going west, right, this is going to be 58 degrees here. And then you're able to draw your horizontal and your vertical component, nice and color-coded for you. Okay, and then remember, theta is going to be the one in your triangle. And then you are able to label that opposite, adjacent, and hypotenuse if you need to, or you can just memorize that your horizontal component is going to be using cosine law, or cosine, not law, sorry, all the time, and your vertical component is going to be using sine. It's the same every time, it will never change. Okay, so remember that you are finding theta first. So theta is going to be 90 degrees minus 58 degrees. So then theta is going to be 32 degrees. Make sure you find that. You can't use 58 degrees. Okay, so you're going to take your vector, 430 kilometers, and then times it by the cos of 32. So you should get 364.66 kilometers. make sure you put your magnitude in, and then because it is going, oh, this should be west. Okay, and then your this one should be west. Sorry, that's wrong. Okay, your vertical component is going to be that same 430 kilometers, and then it's always going to be sine, and then you're going to go 32. So then 227.87 kilometers, and then because it's going south, it's going to be like that. Okay. Again, same thing. We're going to go through one more example of doing the exact same thing. Horizontal, always cosine. Vertical, always sine. Okay. An aircraft is traveling at 900 kilometers an hour at a heading of south 35 degrees east. Okay. Determine its perpendicular component. So that means it's vertical and horizontal components. That's the same thing. Horizontal, vertical components. Okay. So an aircraft is traveling at 900 kilometers, so draw at 900 kilometers. And then we know that it's south 35 degrees and then east. Okay. So that taking it and drawing those actually might take you a little bit of time, but it's good practice with this stuff. Okay. And then you're going to draw in those vertical and horizontal components. Okay. Then you need to find your theta, and you can label opposite, hypotenuse, and adjacent. Not necessary though, because remember, horizontal is always our cosine and vertical is always going to be sine. Okay, so theta here, 90 minus 35 degrees, so it'll be 55 degrees. Okay, so you're going to use that to find your horizontal component, which is your x. You take your vector 900 kilometers an hour and do it times the cos of 55. You should get 516.2 kilometers an hour east, which again, because it's going this direction. Okay. Then find your vertical component, which is always your y, and it always is sine. Okay, take that 900 again, sine of 55. And then it's 737.2 kilometers an hour, and then your direction would be south, it's going down. Okay, so your homework, again, is pretty repetitive. Just make sure that you are understanding how to calculate your horizontal and vertical components or your perpendicular components, okay? Same thing every time. You just have to look back at the lesson and refer to those examples, and I'm sure you'll be fine, but let me know if you have any questions on your homework. Good luck.